The dog's being so bossy this morning. I just sat down to come to class, and then she's like, no, I need to go outside. Okay, take her outside. All right, so last day we introduced, so I'm just looking at the notes from last day just so we don't have to write them all out again because we are a little bit, it's a quick class today. So we're a little bit short on time. All right, we introduced these two special triangles that we can use as an aid to help us remember what these terminal points are at these kind of common cutoff points. So the first one is pi over 6, and then we have pi over 4, and then we have pi over 3. And in degrees, right, so pi over 6 in degrees is 30 degrees. Pi over 4 is 45 degrees. Pi over 3 is 60 degrees, and pi over 2 is 90 degrees. Okay. So we only focused on the first quadrant here, but I'll give you a diagram and I'll post it after. I forgot to post it now, and I'm not actually sure if it's something that I'm allowed to post or whatever, but we'll use the full circle for the problems that we're doing today. So there are two problems, right? Either you have an angle and you need to find the terminal point, right? So the terminal point being, okay, where do you land on the unit circle? And the unit circle keeps going around and around. But you can rearrange those special triangles, and just remember that if you're on the left-hand side of the origin, right, then you've got a negative x, and if you're below the x-axis, then you've got a negative y, or some combination. So if you have some angle, you'll need to find the terminal point, right? So you boil down the angle to be between negative 2 pi and 2 pi. Okay. We also established last day that if you have a positive angle, then you're moving counterclockwise, right? Just like we saw here, these are positive angles. If you're moving clockwise, then you've got negative angles, but they behave the exact same way in the negative direction. Okay. If you have to find an angle, then you're given a terminal point, and then you have to find the angle that corresponds to that point. One thing to keep in mind is that, okay, well, you can draw your point on the circle, your terminal point, and then, but just remember that, okay, there's the core angle, let's call it, between 0 and 2 pi, if we're talking positives. That'll give you that terminal point, but then every cycle around the circle is a distance of 2 pi, right, in radians, or 360 degrees if you're talking about degrees. But we're going to focus on radians, mostly because we're pretty comfortable with degrees, but often we have to do math in radians, and so we're going to focus on the radians, maybe sprinkle in some degrees if we have time. Okay. So what you do is you find that, let's call it the core angle, right? That gives you that terminal point that you've been given. And then you add multiples of 2 pi, right? So 2k pi, where k is in the set of integers, integers being counting numbers, right? 0, 1, 2, 3, 4, 5, etc. Okay, so today, first things first, the following unit circle will be helpful in solving a lot of these problems. Oops. In solving many trig problems. Oops. Thanks. This doesn't really say many, does it? Okay, so I'm gonna give it to you. So I'll put it in here. So it'll be in the notes for sure. And hopefully, I didn't check with Shaun to see if he was okay with me giving you this. This is something that you could develop on your own, right? We actually did the first quadrant last day, right? We set up the special triangle for pi over 6, and then we established that the x point would be root 3 over 2, and the y point would be 1/2. The only difference here is that we actually have 1 over root 2, okay? So one thing that I will point out here is that, just a note, root 2 over 2, or actually maybe I'll start with what we have. We have 1 over root 2, okay, is going to be the same. So all they've done is they've rationalized the denominator, right? So they've moved that square root from downstairs to upstairs, so from the denominator to the numerator. And so this is going to be the same as 1 over root 2 times, how do we rationalize? Well, we multiply by that root, so times root 2 over root 2, right? Root 2 over root 2 is just 1, so we're multiplying by 1, we're allowed to do that. So 1 over root 2 times root 2 over root 2, root 2 times root 2 makes 2, right? So this becomes root 2 divided by 2. So whenever you see 1 over root 2, that's the same as root 2 over 2, right? So here we've got root 2 over 2. With the special triangles, we landed on 1 over root 2, but you can easily get to just root 2 over 2. So I just want to highlight that, that these are the same. Even underline it. Okay, so besides that, everything else is the same as what we found last day, right? We've got these key cutoff points, pi over 6, pi over 4, pi over 3, pi over 2 is the quarter-way mark. And then we can keep going all around the circle, right? Remembering that the full distance around the circle is 2 pi, right? And then we also established that the half circle is just pi, right? Half of 2 pi. So if you're moving counterclockwise, all these angles are positive, right? It might be the case that it's easier to talk about negative angles, right? But notice what's going on here is that you're actually flipping this first quadrant, you're flipping it down to the second quadrant. So 11 pi over 6 is the same as, so it's the same distance as pi over 6, but in the negative direction. Right, so 11 pi over 6 is actually negative pi over 6 if you prefer. So you can say that this is or negative pi over 6. Right? Here, 7 pi over 4 you can rewrite as negative pi over 4 if you prefer. Right? Or negative pi over 4. And so then you can move through the circle in a clockwise direction and make negative angles. And sometimes it's a little bit cleaner to talk about negative angles. And then of course here, 5 pi over 3 is the same as negative pi over 3. Just remembering that negative directions, right, just means you're moving clockwise instead of counterclockwise. Okay. We also established that, okay, so these values here, all these pi values are angles, right? Angles in radians. And so if we take the cosine of pi over x, that actually is the x value of the terminal point, right? So the terminal point of some angle theta, which I can't remember if we established So this is spelled theta, and it's just a typical placeholder for an angle. So the terminal point of some angle theta is pxy, which is going to be the cos of theta, comma, the sine of theta, right? So whatever the angle is, and notice that these values here, the 11 pi over 6, 7 pi over 4, etc., or negative pi over 6, negative pi over 4, and so on and so forth, those are all the angles, right? And then the terminal points are the ones that are given out here, right? So those are all the terminal points on the unit circle. Now, the x value is the cosine of that angle, and the y value is the sine of that angle. Okay? So now we can do stuff like, all right, and I'll even highlight here that this is the x and this is the y. Okay? So for example, find the sine of pi over 6 without using your calculator. Okay, so now, right, pi over 6 is an angle, so I need to find that angle on this circle. Luckily, it's one of those angles. Sometimes, a lot of the time, it will be one of those angles that are listed, for example, 7 pi over 6 or 5 pi over 4. Sometimes it's moving in the clockwise direction, so then you might want to jot down what they are, what these angles are moving in the negative direction, right, so clockwise. But then you'll have these all, and they'll be available for you to refer to. So if we have to find the sine, well, sine is just the y value in the terminal point of pi over 6. So pi over 6, we see here, pi over 6 has a terminal point of root 3 over 2 and 1/2. We see theta equal to pi over 6 has a terminal point at root 3 over 2, 1/2. Okay. So that's just from this, this unit circle that I'm giving you. And so, or that you could establish on your own if you prefer. But you'd have to kind of work with those special triangles, but it might be a really good exercise to, it would be a really good exercise to work with those special triangles and try to fit them in and use those to find, to confirm all of these points, or you can just use them. Right, maybe easier. So here, right, my y value, y is 1/2. Sine of theta is going to be the same as the y value at that terminal point. So now what we can say is the sine of pi over 6 must be 1/2. So therefore, the sine of pi over 6 is 1/2. Okay. Let me just fix one thing here. Okay, good. So, okay, what if we have to find, let's do another example. Find the cosine of pi over 4. Okay, I'm not going to do as much explaining here, right? But the cosine is the x value in the terminal point. So from pi over 4, I need to find the terminal point. Okay, the terminal point for pi over 4, the terminal point here is root 2 over 2 and root 2 over 2. And remember, if you prefer to have 1 over root 2, that's fine. Then it would be 1 over root 2 and 1 over root 2. Okay, so it doesn't matter which one you prefer. They're the same, right, as we showed over here. So pi over 4 has a terminal point of root 2 over 2 and root 2 over 2. And so the x, so the cosine of pi over 4 is root 2 over 2, and the sine of pi over 4 is root 2 over 2. So now we can just say is root 2 over 2 or 1 over root 2, if you prefer. What if we have to find the terminal point? Find the terminal point for these two values. For theta equals 7 pi over 6. Yeah. And for theta equals, so let's call this A and let's call this B. Theta equals negative 5 pi over 4. Yeah. Okay. The first one, not too bad. I'll bring this, this unit circle in, copy. So we can refer to it, paste. I'll clean it up a bit here so it didn't transfer all the stuff there. Okay, so 7 pi over 6, 7 pi over 6, I see the angle here, right? So from this circle, I can just pull the terminal point from the circle. So that's great, that's easy, right? And from the terminal point, I know the cosine of 7 pi over 6 and I know the sine of 7 pi over 6. Okay. So I'll put that there. Maybe I'll put it in the middle here. So terminal point of 7 pi over 6 is, and I'll just steal it from here, negative root 3 over 2 and negative 1/2. Notice, right, in this third quadrant, so here we're in the first quadrant, second quadrant, oops, third quadrant, and the fourth quadrant. Okay, and I'll ditch this Q here, I'll just do 1. So in the first quadrant, all values are positive, right? X is positive and Y is positive. In the second quadrant, my X's are gonna be negative, right? And my Y is gonna be positive. So here you see all these X's are negative, right? Which means all my cosines are negative. Here, when I move into the third quadrant, I know my X's are negative as well as my Y's are negative, okay? So now both coordinates are negative, right, to match that. Here in my fourth quadrant, I'm back into a positive X, right, but still have negative Y to deal with. So I'm seeing positive X values and negative Y values. Okay, so here, right, 7 pi over 6 was on the circle, so we just were able to find the terminal point. Okay. Not quite as obvious is negative 5 pi over 4. Negative 5 pi over 4, the negative just says I need to move clockwise. Move clockwise. Okay. So 5 pi over 4 in the clockwise direction, okay? So now I need to remember, okay, well, 4 pi over 4, that's gonna be a full pi, right? 4 pi over 4 is pi. So now I need to move plus another pi over 4. So what ends up happening is I end up going 1 pi over 4, so that's negative pi over 4, negative 2 pi over 4 is pi over 2, yeah, okay, good. Negative 3 pi over 4, negative 4 pi over 4, negative 5 pi over 4 is the same as 3 pi over 4. So negative 5 pi over 4 is 3 pi over 4. Right? They're the same angles. So negative 5 pi over 4 is the same as 3 pi over 4. So the terminal point then is going to be the negative, and if you prefer 1 over root 2, that's fine. Negative root 2 over 2, root 2 over 2. Terminal point is negative root 2 over 2, root 2 over 2. Or negative 1 over root 2, 1 over root 2. Doesn't matter. Okay. What if, so for example, what if we have to find all the angles if we're given a terminal point? So now we're just working through those two scenarios that we established last day, right? Just doing some examples. So what if we have to find all angles? Find all angles for which the terminal point is, okay, we'll start with a negative 1/2 root 3 over 2. Okay. And b, negative root 2 over 2, negative, actually, you know what? Negative 1 over root 2, negative 1 over root 2. Okay. I changed it because the way Shaun has it in his notes is negative 1 over root 2. So I just want you to get in the habit of seeing so 1 over root 2 and thinking, if you're matching it to the circle here, thinking root 2 over 2 is the same thing. Right? So I'll just make that note right away here. That's the same as negative root 2 over 2, negative root 2 over 2. Okay. So there are a couple of things I know already from just the coordinates here. My x is negative, my y is positive. So where does that happen? Well, I can zoom in here. My x is negative, my y is positive, so I must be in Q2. So I can focus my attention here in the second quarter. And so I can ignore the rest, or if you prefer, you can scan the whole circle here until you land on that terminal point that you're looking for. About the same amount of work, right? But it's all on here. So I'm looking for negative 1/2 root 3 over 2. Hey, looks like I found it. This is the point, right? Negative 1/2 root 3 over 2. And it corresponds to an angle of 2 pi over 3. So we see that theta, if you prefer, I think maybe last day we were using t's. You can use t's or thetas interchangeably. But just to kind of get you, I don't know, working in thetas, I've been using thetas, but you can use or t if you prefer. Okay, so the angle that gives me that terminal point is going to be 2 pi over 3. Notice that there are no other points that give me this exact terminal point. Right? So this is the only time that happens, at 2 pi over 3. But the thing is, I could move another 2 pi, right? So 2 pi over 3 plus 2 pi gets me back to that same terminal point, plus 2 pi gets me back to that same terminal point, plus 2 pi takes me back to that same terminal point, right? So I can add on multiples of 2 pi and it still end up at that same terminal point. So what happens is what we do, plus 2k pi for k in the set of integers. I'm going to clean that up. Okay. So z is the set of integers, right? So I can move 1 2 pi, 2 2 pi, 3 2 pi, 4 2 pi, right? Just multiples of full revolutions. I can even move in the negative direction, right? As long as I'm moving a full distance of 2 pi, right? I can move, sorry, I went counterclockwise when I said negative 2 pi. So from 2 pi over 3, I can move negative 2 pi and still end up at that same point. Okay. So I can move in the positive or negative direction. So you can just add or subtract multiples of 2 pi and still end up in the same place. So when it says find all angles, right, we just need to add on. So we find the jumping off point, right, how I think of it is the core angle, and then I add multiples of 2 pi just to cover all my bases. All right, how about negative root 2 over 2 and negative root 2 over 2? Notice that I'm using this one because that's the one that matches the circle that I have up here. Both values are negative. X is negative, Y is negative. That means I must be in the third quarter over here. So quartile, quarter, it escapes me, doesn't matter. Q3. So I'm looking at negative root 2 over 2, negative root 2 over 2. Looks like the angle is going to be 5 pi over 4. So 5 pi over 4 gives me that terminal point. And so here, theta is 5 pi over 4. But then in the same way, I can move multiples of 2 pi, either clockwise or counterclockwise. So plus 2k pi, where k is in the set of integers, z. Kind of a fancy, bold z. Okay. What if we have to find something like, what's the sine of 3 pi over 4? Okay, going back to where we started, right? 3 pi over 4 is probably on this circle. It sure is. 3 pi over 4 is over here. If I only want the sine of that angle, that's going to be the y value, right? So root 2 over 2 equals root 2 over 2, or if you prefer, 1 over root 2. What if we have to do something like the cosine of 25 pi over 4? That's a little bit harder, right? 25 pi over 4 looks like I've done some revolutions, right? So 25 pi over 4, I need to boil it down to just that core angle. So I take away multiples of 2 pi until I can't take away anymore, right? So here, cos of 25 pi over 4, we need to remove full revolutions of 2 pi. So what we get is 25 pi over 4 is the same. So if we're over 4, right? Remember, a full revolution is 2 pi. And so over 4, 8 pi over 4 would be a full revolution. So I'm removing multiples of 8 out of 25. So what I get is I get 8 pi over 4 plus, and I would use my calculator on the side, right? Do 25 minus 8 is 17. Okay, so it looks like I can still subtract 8. So plus 8 pi over 4, just keep track as you go here, puts me at 9 pi over 4. It looks like I can still subtract 8. So 8 pi over 4 plus pi over 4. 8 plus 8 plus 8 plus 1 makes 25. Okay, over 4, common denominator, so we're allowed to split them up. Okay. So here's a full revolution, full revolution, full revolution. Essentially gets me back to the starting point. Nothing's happening until this pi over 4. That's the angle that I'm going to be looking at. Right? So here, this is full revolutions of 8 pi over 4, which is actually 2 pi, right? So that's why we did multiples of 8. That's always determined by whatever's in the denominator. Okay, so here, this determines our terminal point. This determines the terminal point. Okay. So we're trying to find the cosine of this thing. From the terminal point, the x value is the cosine, right? And so 25 pi over 4 is going to end up at the same place as pi over 4. So pi over 4 has a terminal point, or the terminal point, I guess I could say. If I look here, pi over 4, positive pi over 4, root 2 over 2, root 2 over 2. Root 2 over 2, root 2 over 2. Okay. Therefore, the cosine of 25 pi over 4 is the same as the cosine of pi over 4, which in the end is going to be root 2 over 2, right? Or 1 over root 2 if you prefer. Maybe I should label these A, B, because we're about to do a C, but it's been so long that we've done one. So we worked on that cosine 25 pi over 4 for a while. So I should label those. But now we're going to find the cosine of negative 14 pi over 6. Same idea, just keeping in mind that a negative angle just means we're going to go clockwise, right? And notice here, so 6, so we're over 6. So 12 pi over 6 would be a full revolution. It looks like I'm able to extract 12 pi and just have a core function to work with here. And so here, negative 14 pi over 6 is the same as negative 12 pi over 6 plus negative 2 pi over 6. Negative 2 pi over 6 is the same as negative pi over 3, right? I mean, it doesn't actually matter if you break your circle into sixths or thirds. You're either moving 1/3 or 2/6, they're the same, right? And so here, negative 2 pi over 6, which is negative, I'll say negative 2 pi minus or plus negative pi over 3. I'm doing the plus because I want to keep that negative on the angle because I want to emphasize that I'm moving clockwise. Okay, so this negative 2 pi puts me right back. So if I'm starting here on the positive x-axis, which is where we start, and I move negative 2 pi, well, really all I'm doing is I'm just doing a full revolution clockwise, ending back to where I started, and then I'm moving negative 2 pi over 6 or negative pi over 3. Okay. Putting me here, so now I have my terminal point of 1/2 negative root 3 over 2. Okay. So what we can say is negative pi over 3 has a terminal point. I guess I should be saying the terminal point. As the terminal point, and now I lost it. It was 1/2, yeah, 1/2 negative root 3 over 2. And if I want the cosine of this thing, right, negative 14 pi over 6, we've boiled down to negative pi over 3. They're going to have the same cosine. And the cosine is the x value in the terminal point. So what we can say is that we can say, therefore, the cosine of negative 14 pi over 6 is the same as the cosine of negative pi over 3, which in the end is going to be 1 over 2. Okay. So let's, more examples. Today's example day. That's good. Because this stuff is hard, right? But make sure you have some copy of the circle, and you'll see that it really helps and makes things a lot quicker and easier.
Quick question.
Oh, yeah, sorry.
I'm not quite understanding how you went from negative pi over 3 to the 5 pi over 3. Is this just
okay.
I assume this is in part an intuitive thing for you at this point. But.
No, I'm terrible at trig. So, yeah, I am no good at trig. But so what I did was I moved, because it's negative, right? You're starting here on the x-axis, and then you're moving clockwise because it's negative. And so if you ignore this 5 pi over 3 and you kind of flip this top half down,
okay,
right?
I see. Yeah.
Then you're getting to negative pi over 6. So up here, 11 pi over 6 is the same as negative pi over 6. 7 pi over 4 is the same as negative pi over 4. And 5 pi over 3 is the same as negative pi over 3, if you're just moving in the negative direction.
Okay. Okay.
Does that make sense?
Yes.
Cool. It's hard. I'll give you that. It's hard. And yeah, there's, besides having this circle handy, I'd say this is like the easiest way to do it, is just to have the circle and just kind of move around the circle. And you can keep going, right? You can keep going with your, so here, if you're moving clockwise, this would be negative pi over 2. This would be negative, oh shoot, here, let's see, pi over 3, negative 2 pi over 6, 3 pi over 6, no, 3 pi over 6. See, I told you I'm terrible. Yeah.
Negative 2.
Negative pi over 6.
Negative 2 pi over 3.
Negative
right
3 pi over 6. Yeah, negative 4 pi over 6. Yeah, negative 2 pi over 3. Hey, nice work. You got it. That's awesome. Yeah, so here, these outside 2 points are multiples of pi over 6, and then these halfway marks are quarter marks. right. Well, yeah, let's do a couple more examples here. I'll put on a fresh page. Find all angles for which sine t. I've been using theta. We can use t, like I said, so just see those and use them interchangeably. Sine of t is -1/√2. Okay. Now, I'm going to grab that circle again because we're going to use it once more. And I don't want to be scrolling around all the time. So remember, the sine of an angle, so here, how we could write this alternatively, so or this could say sine of theta is -√2/2, right? You can swap the theta for a t or t for a theta, and then 1/√2 you could also rewrite as √2/2 to match the circle that we're looking at. Okay? But this, so sine tells me that the y value in my terminal point has to be -√2/2. So y value in terminal point is -√2/2. Okay. So I know the y values are negative down here, right? In the third and the fourth quadrant. Quadrant, that's the word. I don't know why I couldn't think of it earlier. So that happens, -√2/2, that's here, as well as here. So now I've got two values that give me a sine of that angle, so some angle. Turns out that angle is 7π/4 or 5π/4, or if you prefer, you can work in the negative direction, right? -π/4, -π/2, -2π/4, -3π/4, right? So here, this point is -π/4 as well as 7π/4. This point is -2π/4. And this point is -3π/4. So whether you like to work in negative angles or in positive angles, it doesn't matter, right? Here, I just did this one. We're not going to use this one, but just so you can see that this is actually a quarter way mark as well, right? So there's actually two angles, right? 7π/4 and 5π/4. If we're talking about the positive angles, there are two angles that give me this y value, right? So this sine equals -1/√2. We see there are two values or two angles that give sine theta equals -√2/2. Okay. In the positive direction, we can have 5π/4 and 7π/4. I'll move this over just a little bit here. Or in the negative direction, it doesn't actually matter, right? The terminal point stays the same, so you can use whichever one. I would just encourage you to be consistent, right? If you're going to use a positive value for one, you should probably use the positive value for the other one. If you're going to use a negative value, use negative values for both. So in the negative direction, negative pi over 4 and negative 3 pi over 4. So we know that these values, right, let's look at this point here, for example. If I go multiples of 2 pi again, I'm going to end up at that same point, right? So go around 2 pi, I end up at the same point. Go around 2 pi, I end up at the same point. But also, the same thing happens from this point, right? I go around 2 pi, I end up at the same point. Go around another 2 pi. Right? And so from each of these, I'm going to add multiples of 2 pi. So theta is 5 pi over 4 plus 2k pi, where k is in the set of integers, and theta is 7 pi over 4 plus 2k pi, where k again is in the set of integers. Okay. I think, no, I think that's good. I'll leave this example for next day. All right. It's such a quick class on Fridays. I can't get over it. It's crazy. Any questions? I know I'm basically out of time pretty well.
Not currently, yeah, not currently.
So I saw, yeah, I saw Shaun posted that you're not going to have to submit any assignments anymore, but have a look at those problems that are there for 5.1. I'm glad he posted the solutions. I haven't had to check. I haven't checked the solutions, but there's something. I think there's a typo in the problem for 5.1, but you're able to do all those now. So the 5.1 problems, have a look at those, see if they kind of jive.
All right, will do, and I'll see you Monday.
A rogue cosine in one of the questions, but anyways.
Mm-hmm.
All right. Have a good weekend, you guys.
You too.